भावना सिंह एंड वेलकम बैक टू इनसाइटोनॉमिक्स। कैसे हैं आप सब लोग? आई होप आप सभी लोग बहुत अच्छे होंगे, हेल्दी होंगे। एंड आज का टॉपिक है लीनियर यूटिलिटी फंक्शन एंड डेरिवेशन ऑफ डिमांड फंक्शन। तो हम लोग डिमांड फंक्शन डिराइव करेंगे यूजिंग लीनियर यूटिलिटी फंक्शन। हमारे पास केस स्टडी है दैट वी हैव टू मैक्सिमाइज द यूटिलिटी गिवन द बजट कंस्ट्रेंट। हमारे पास इनकम गिवन है, हमें यूटिलिटी मैक्सिमाइज करनी है, तो उसके लिए हमें एक्स और वाई की वो क्वांटिटी चाहिए, ऑप्टिमल क्वांटिटीज जो हमारी यूटिलिटी को मैक्सिमाइज करें। तो हम लोग लेग्रेंज मेथड यूज करेंगे डिमांड फंक्शंस फॉर एक्स एंड वाई डिराइव करने के लिए। लेट अस स्टार्ट। फर्स्ट सेटअप लेग्रेंज।
पहले नॉर्मल मेथड से हम कर सकते हैं इसे सॉल्व।
Yeah, we can, but I think Lagrange is much better than that. Bit formal.
ओके।
We will multiply the constraint with the lambda. Lambda is the Lagrange multiplier. Then we will get equation like this. Lambda represents, in our earlier video, I've also told you what lambda represents. It represents the unit change in objective function. In our case, that is utility. Is a result of the unit change in constraint. That is the budget in our case. सिंपल टर्म्स में अगर एक यूनिट से आपके इनकम में चेंज आता है तो वो आपकी यूटिलिटी को कितने यूनिट से कितने टाइम्स अफेक्ट करेगी, ये आपको लेमडा बताता है। लेमडा इज द लेग्रेंज मल्टीप्लायर। लेग्रेंज सेटअप करते हैं, लेग्रेंज एल से नोट किया जाता है इसे। देन वी विल पुट ऑब्जेक्टिव फंक्शन प्लस lambda and your constraint. Our objective function is ax plus by plus lambda m minus price of x into x minus price of y into y, where a and b are constants x and y are goods that the consumer consumes. Linear terms implies that as you consume more of x and y, your utility will increase as at a constant rate. It won't diminishes. Good x and y are substitutes. Example like tea and coffee. So we can say that in case of substitute goods, our utility function will look like this only. So in this case, your MRS is a straight line, a downward sloping straight line. We can put it like this. This is your MRS, or if the slope, MRS represents the slope of your indifference curve. This is your IC. What is MRS? MRS represents the change in Y due to change in X. Here we are taking X, and on Y axis we are taking good Y. This is point A, this is point B. This is your IC, indifference curve. In case of linear utility function, the slope is constant everywhere. That implies that the law of diminishing applied in case of substitute goods. Consumer will get same satisfaction even that consumer is consuming only good X or only good Y. Example, tea and coffee. Other example can be like beef and chicken. They are almost substitute. Now we put the value in our Lagrange setup like this. Well, our objective function is ax plus by plus lambda m minus price of x into x minus price of y into y. Now we will take partial derivatives with respect to x, y and lambda like this. So we have to differentiate the whole term with respect to x. Differentiation of ax will give you a plus, here we are having x, then we will get lambda px. Sorry, it's the sign will be negative. We will put it equals to 0, then we will get a is equal to alpha px as your equation 1. Similarly, differentiate L with respect to y, then we will get b minus lambda price of y equals to 0 and b equals to lambda py. This is our equation 2. Similarly, differentiate L with respect to lambda, then we will get m minus price of x into x minus price of y into y equals to 0. We will get our budget function. This is our equation 3. Now, divide equation 1 with respect to equation 2. Then we will get a beta is equal to lambda price of x, lambda price of y. Lambda cancel out. We'll get ayb is equals to price of x by price of y. As we know, graphically, the utility, just wait. At equilibrium E, where your MRS is equals to your budget line, that is price of the tangency point between your budget line and your indifference curve represent the condition for the maximum utility, where the consumer gets the maximum satisfaction given the budget constraint. But in this case, the good X and good Y are substitute of each other, and the MRS is a straight line. Then you got infinite points where the utility can be maximized like this graphically. As the slope of IC and the budget line are equal to each other like this. Then you will get multiple equilibrium points between point A and B. Because your IC and your budget line are coinciding to each other. So you will get infinite equilibrium points. In case of consumer theory, equilibrium E denotes the maximum utility given your budget constraint, or minimum expenditure given the utility. So, like as we know, MRS is the del Y, del X. This is equals to A by B. Then A by B represent the MRS, the slope of IC. Similarly, price of X, price of Y represent the slope of your budget line. This represents the equilibrium condition. At this condition, the point A and point B, we are having infinite solutions and other cases like that. This is the case 1. Like I will put it like this. Case 1, where your MRS, that is MUX, MUY is equals to price of X, price of Y. In this case, you will get infinite solutions, infinite points between point A and B, between point A and B. But you won't get unique solution. That means, like in case of normal goods, you got one point of equilibrium. That is the tangency of your budget line and your IC. But you won't get such results in case of linear utility functions, where good X and Y are substitute of each other. In this case, you will get corner solutions. That means a consumer is consuming only good one. That can be good X, that can be good Y. That's why we are just referring that as a corner solution. Case 2, where your MRS, that is equals to your marginal utility of X, marginal utility of Y, is greater than your price of X, price of Y. In this case, a consumer is getting more utility by consuming that particular good X. Then, because good X and Y are substitute of each other, so in this case, the consumer will refer only good one, that is good X. So we will get interior solution like this. Graphically, I can put it like this. Suppose this is your budget line. As we know, MRS represents the slope of your IC and price of X by price of Y represents the slope of your budget line. So this is your budget line. In this case, your MRS is higher than your price line. That means the slope of IC is steeper than the slope of your budget line. Then you will get only one point of intersection between the two. That will be like this. So in this case, there is only one point of tangency, that is point B. So consumer is consuming only good X. So you will get equilibrium condition X star and Y star like this. Consumer is consuming only good one, good X in this particular case. This is your equilibrium. Point B represents your equilibrium. Case 2, case 3, where your MRS, that is MUX by MUY, is lesser than your price line, like this. In this case, a consumer is getting less utility by consumption of good X, and like oppositely, we can say that a consumer is getting more utility with the consumption of good Y. So as they are perfect substitute of each other, so consumer will consume only good Y. Graphically, we can put it like this. This
I
is
have
your
one
budget.
doubt in previous section.
Okay, what's that?
Uh, there is X star and Y star. Okay. Then you
Hmm.
have taken M upon price of X and then zero.
Hmm.
What does
Hmm.
that what does this case represent? I haven't
Oh, okay, okay.
I don't I'm not getting it.
Okay, okay. We'll explain. Don't worry. As we know, our budget function looks like this.
Yes.
Graphically, what this graph is representing that you are consuming only one good. Y is 0 at point B. Okay.
Okay. Okay.
So when Y is 0, this whole term turns 0. Okay. Then you will
Okay.
left with price of X into X. Now you will have to like separate it with respect to type X. Then you will get like this. This is your X star.
Okay. Okay. Got it. Got it.
Okay.
Yeah. Yeah.
Now, in case 3, as MRS is lesser than your price line, that means the slope of your IC is lesser than the slope of your budget line. Then we will, in this case, consumer is consuming only good Y. Then we can put it like this. Are you getting the point why I am drawing like this?
Because we are just consuming only one good here. That is
Yeah,
why. And
it is like that only. And why we are consuming only good one? Because they are perfect substitute of each other. So it won't make any difference to the consumer if that consumer will switch on to other good.
but elaborate this diagram. That would be more helpful.
Okay. This is your IC. This is your budget line. Okay. Where we get the
Huh.
equilibrium? Equilibrium is the point of intersection between your IC and your budget line. Okay. Then you are getting
Yeah,
only
and it
this
is
point.
only
Only you are, yeah,
hmm,
you are only getting point A, where both are
where.
intersecting to each other.
Okay, okay, got it. And why this
Okay.
line has shifted outward, that the IC curve has shifted outward.
This is our case. Your MRS is lesser than your budget line.
Okay, so the slope of IC curve will be less than
Lesser,
budget line.
yeah. So in other words, we can say that your IC is bit flatter than your budget line.
Okay.
Okay. So
Now got it.
these are the corner solutions.
Okay, got it.
That means consumer will consume only one good, only one good in order to maximize the utility. Because they are substitute of each other. Like Pepsi and Coke, they are substitute of each other. So even the consumer is consuming like only Pepsi, like either Pepsi or either Coke. That won't make much difference to him. Okay, I will explain like with that example. We are taking the example of Pepsi and Coke. Okay, this is the case where case of case one, the consumer is getting the same satisfaction with the consumption of both the goods. That is Pepsi and Coke. Okay, but in case two, this is the situation where the consumer is getting like suppose Pepsi is your good X and Coke is your good Y. The consumer is getting more satisfaction with the consumption of Pepsi than your Coke, and they are substitute of each other. Then, as a rational consumer, the consumer will consume only Pepsi rather than Coke. And in case three, the consumer is getting more satisfaction with the consumption of Coke rather than your Pepsi. Then the rational consumer, in order to maximize their utility, will consume only Coke. because they are substitute of each other. So in case of linear utility functions or in case of substitute goods, you will get only corner solutions. That is, the consumer will consume only one good. So in this case, you can write the equilibrium condition x star y star like this. You are consuming x0, you are consuming only y like this. This is your equilibrium condition. M by px represents your demand function, py, and in this case, this is x star and y star represents the optimum bundle of x and y, where the consumer get the maximum satisfaction given the budget constraint. Okay. So we have derived demand function x star and y star. Now we can derive indirect utility function using these functions. Indirect utility function IUF. This represents the maximum utility the person can get with the consumption of x star and y star. Okay. This is a function of price of x, price of y, and your income.
Hello.
Yeah.
We can derive indirect utility function from the above functions.
Yeah, definitely. Simply we can put x star and y star in our linear utility function and then we will get the indirect utility function.
Okay, so in initial cases, we got x star is equal to m upon price of y. Sorry,
In
price of x. I think
yeah,
price of y, no?
yeah,
हाँ,
like these are three cases. In this
हाँ.
case one, you won't get only one solution. You can get any point between
There
A
are
and Y.
infinite solution.
Yeah,
हाँ.
infinite
And in case,
solutions.
and in case two, we are getting x star is equal to m upon p of x. Px.
Yeah. So
And in case three, we are getting x is equal to 0 and y star is equal to m upon price of y.
yeah,
So we are deriving indirect utility function from these two cases, na, not of one
yeah,
first case.
yeah, like
Because
from
in
these
first
two.
case there are many, there are
Yeah.
many possible
Mm-hmm.
solution. Okay,
Yeah,
okay. So we
you're
are
right.
deriving indirect utility function from the case two and case three only.
Mm-hmm.
Okay, okay, okay. Fine.
Like we can write our utility function AX plus BY. Now we will put, like we are taking case one when consumer is consuming, like case two, only X. Consumer is consuming only X, then your X star will be M by PX and your Y star will be 0. U is equal to A M by PX, okay, plus B, your 0, then you will get A M price of X, U. It's represented by V, U bar, because this is constant. This is the maximum utility that the consumer can gain with the consumption of good X and Y. This is your indirect utility. Similarly, for case 2, case 2, case 3, sorry. A consumer is consuming only good Y, then Y star will be M by PY and X star will be 0. Then we will get V bar is equal to A 0 B M by PY. So you will get like this. This is your indirect utility function when consumer is consuming only Y. Okay. And similarly, we can derive expenditure function from it as well. As we know, expenditure function is the inverse of your indirect utility function.
So in case of in expenditure
Okay.
function, we will derive
Mm-hmm.
that from the above section.
Yeah, we denoted by E. Expenditure is a function of price of X, price of Y, and your V var. We can derive it like case 2, where your V var is AM by PX. So simply like at equilibrium, your income is equal to your expenditure. A consumer is like spending all their income. Okay. So we can put E at place of M, then we will get, as we know, we have to derive the whole equation in terms of your expenditure function, then we will put extra term to other side like this. Then we will get V var price of X divided by A. Okay. We can rewrite in terms of expenditure function it like this. This is your expenditure function when consumer is consuming only good X. Okay, clear?
Yes, yes, got it. It is the case where the consumer consume only X.
Only X.
Okay, and for Y, similar we can derive for Y also.
Yeah, similarly, like very easy. Case 2, sorry, case 3, where consumer is consuming only Y. We will get V var like this. What is our V var? It's B M by P Y. So we can also do the same. V var price of Y by B. This is our expenditure function for good Y. So we have derived demand functions and there are different cases in it. Case 1, you will get infinite solutions between point A and point B. There is no unique solutions.
And
But
hence,
in
we can't derive indirect utility function from case 1
yeah, it
because
sorry.
there exist a lot of solutions.
Yeah, like there are infinite solutions. You won't get one unique solution, one unique point of equilibrium where you can say
Yes,
this is
yes.
the point of equilibrium where your budget line is tangent to your indifference curve because they are coinciding to each other.
Okay, okay, got it.
Yeah, like in normal cases, like this,
You can move that line by your fingers. Don't use pen. It can be moved. Hmm.
okay, like this, okay. This is the point of equilibrium. This is your IC. This is your budget line, okay. And this is then in like this is good X, good Y. Here both goods are normal goods, okay. In this case, your IC is convex to the origin. You are getting one point between A and B, that is E. This is a unique solution that representing your X star and Y star. Optimum units of X star and Y star that will maximize your utility. Okay, but unique solution. But in the case of linear utility function, the case is different. The scenario is totally different. Okay, because they are good, like both goods are substitute of each other. Consumer will get the same satisfaction with the consumption of any of the good. But in case of normal goods, as you consume more of X, the utility deriving from that particular good X will be like diminishes, right? But in case of linear utility functions, the utility remains constant. It won't diminishes. That is represented by the constant MRS. The slope is constant. That means the utility is constant with the consumption of the more of additional good of like consumption of good X and Y. The utility is constant. So in case of linear utility functions, you are getting only interior solutions. There is no unique solution. There is no unique point of equilibrium where the consumer can get X star and Y star and you are getting maximum utility. You are only getting corner solutions. That is equilibrium at the corners. Like at point A represents the corner, and similarly point B also represents the corner solution. That means consumer is consuming only one good. In case of point B, consumer is consuming only good X. In case of point A, consumer is consuming only good Y. So you now I hope you will be clear with the term interior solution and corner solutions.
Yes, ma'am. Clear now.
Okay. And like ये टॉपिक हो गया है कंप्लीट. मैं डिमांड फंक्शन डिराइव करने थे, डिमांड फंक्शन डिराइव कर लिए हैं, इनडायरेक्ट यूटिलिटी फंक्शन भी डिराइव किया है, एक्सपेंडिचर फंक्शन भी डिराइव किया है. आई होप आप लोगों को समझ में आया होगा ये टॉपिक.
तो ये लीनियर और कुछ टॉपिक नहीं बच रहे ना अभी.
No, like in this particular topic we are done with everything, every step. तो आज का टॉपिक यहीं फिनिश होता है. थैंक यू सो मच फॉर वॉचिंग. मिलते हैं नेक्स्ट वीडियो में. बाय.